A warm and a happy morning to you all children. I'm extremely happy to meet you this morning to discuss and open up a new topic in physics which is called light. Children, this is a very interesting lesson and we are marking the entry of physics by this first lesson called light. Light is a lesson which is very familiar to you and you have studied a lot and lot in your previous classes. So if you recollect one by one and if you find out the answer for what is light, so you will be able to give me the answer. Light is a source of energy. It is a source of energy. So light is being given out by various sources. The sources may be of two types. They are luminant and non-luminant. For example, sun and candle. So also you would have read about the basic properties of light, like rectilinear propagation of light. That means light travels in straight line, and light undergoes two important properties, reflection and refraction. So all these you have learned in your lower classes. Now what we are going to take up in today's lesson is all about spherical mirrors. Children, when we say about spherical mirrors, let us recollect some of the things we use in our day-to-day life. Have you observed the shape of the dish antenna which is kept on the roof of your house? How do you find it? Yes, it is curved. Also, have you observed the surface behind the bulb of your torch? Yes, it is also curved. Have you observed the shaving mirrors used by the parlors? If you happen to see and touch and see it, it is also curved. So we have so many curved mirrors around us. So mirrors are of two types. One is plane mirror and the other one is curved mirror. A plane mirror is the one which we use in everyday life for dressing purpose. So when we stand in front of the plane mirror, we obviously see our image in the mirror. So as even when we stand in front of curved mirrors, we will see image. But there is a difference between the image formed by the plane mirror and the image formed by the curved or spherical mirrors. That is what we are going to see in detail in this class. So spherical mirrors, are otherwise called as curved mirrors, are of two types: concave mirror and convex mirror. And after learning about these in detail, we are going to see some of the terms used in mirrors, like center of curvature, radius of curvature, principal axis. So we are going to learn about some terms and their definitions. And then we are going to classify the image as two: real image and virtual image. So what is a real image and what is a virtual image also we will discuss. and at the end of the lesson we will be able to identify what is or how to identify a concave mirror or convex mirror, and what are its properties, and what are the terminologies used for those. So children, so we will start one by one and we will go ahead with this lesson.
So, what is a spherical mirror? Spherical mirrors are mirrors whose surface form a part of a hollow sphere. The spheres can be made of glass or any polished metal surface. For example, if you take your football, what is the shape of the football? Yes, it is a sphere. Now imagine the football is made with a completely glass and you are dividing into two equal halves. Then each part of it will behave like a mirror, and since it is curved, we call it as spherical mirrors. There are two types of spherical mirrors. One is convex, the other one is concave. And we will study about the detail of convex and concave in the next slides. This slide gives you the definition for spherical mirrors, concave mirrors and convex mirrors. What is a spherical mirror? A curved mirror formed by a part of a hollow glass sphere with a reflecting surface is known as a spherical mirror. As I told you, when you cut a football equally, then each part of it will behave like a mirror. Now in this, what is a concave mirror? A concave mirror is a curved mirror with the reflecting surface on the hollow side. So a mirror has two surfaces. One is the reflecting surface and the other one is non-reflecting surface. Even in the plane mirrors where you are using for dressing up yourself, it is a plane mirror and you can see the two surfaces. One surface is the reflecting surface where you stand in front of it and see your image. The other part, it is coated with red oxide. So it will be red in color, and that is non-reflecting surface. If you stand in front of the non-reflecting surface, you will not find your image because it no longer reflects the light. Only polished surfaces reflect light. So if the reflecting surface is in the hollow of the sphere, inside the sphere, then it is a concave mirror. A convex mirror is a curved mirror with the reflecting surface on the outer side. On the outer side, if the reflecting surface is on the outer side, then it is a convex mirror. You can see in the diagram. On the concave mirrors, the red color lights are passing and getting reflected, and they are converging at a point F. So the reflecting surface is inside the mirror, and on the other side convex mirrors are there, and you can see the blue color lights. Those lights fall on the outer surface and they get reflected. And this is the major difference between a concave mirror and a convex mirror. A concave mirror will have the reflecting surface inside. Convex mirror will have the reflecting surface outside. So the definition for convex and concave. A convex mirror, if the mirror coating is in the inside of the spherical surface, then the mirror is called a convex mirror. Concave mirror, if the mirror coating is on the outside of the spherical surface, then the mirror is said to be a concave mirror. So that's the simple surface. We can define both of this with the where the reflecting surface is. This slide gives you the extension of the portion formed by both the spherical mirrors, concave and convex. If you look at the concave mirror, the the reflecting surface is inside and the non-reflecting surface is outside. So for that arc of the circle, a complete circle is created using a dotted lines. So it is an imaginary sphere. We can consider this as an imaginary sphere. And you can see a line which divides the circle into two equal halves or semisphere. The line which passes through C and P, where C is called center of curvature and P is called pole of the mirror. And that imaginary line which divides the circle into two, and that line it is called as principal axis. Principal axis is an imaginary line which passes through the center of curvature and pole of the mirror. What is center of curvature? Every circle should have a center. So similarly, this circle is also having a center, and that is called center of curvature. And pole of the mirror. Now measure the length of the reflecting surface of the mirror. Now divide it into two parts, or find the midpoint of the reflecting surface. So the midpoint of the reflecting surface is the pole of the mirror. Okay, so the line which passes through center of curvature and pole of the mirror, it is the principal axis. And the distance CP, it is the radius, right? For a circle, CP is the radius. Here we call it as radius of curvature. So these definitions we will see one by one in the upcoming slides. Similarly, convex mirror can also have its imaginary sphere with the dotted line. Here too, the difference is the reflecting part is outside here and the non-reflecting part is inside here. So C is the center of curvature, where it is the center of the sphere, and P is the pole of the mirror, so the midpoint of the reflecting surface, and the distance PC is the radius of curvature, and the line which passes through the pole and center of curvature is the principal axis. So we will learn the definitions one by one in the upcoming slides. Same phenomena is being illustrated here. So it shows both the concave and convex mirror, and the reflecting surface is inside for the concave mirror and the reflecting surface is outside for the convex mirror. So all of them tell you the same concept, and this I am showing in different slides because this idea has to be imbibed into your mind. First definition is for center of curvature. The center of curvature of the mirror is defined as the center of the hollow sphere from which the mirror has been cut. It is represented by the letter C. It can be observed that C of a convex mirror is behind the mirrored surface. On the other hand, C for a concave mirror is in front of the mirror. As I told you, every circle will have a center, and that center here we call it as center of curvature. You can recall the diagram for the definitions. Once when you learn, you can just go and check the diagram so that the definition and the diagram will go hand in hand. Next is radius of curvature. Radius of curvature is the radius of the sphere from which the mirror, whether it is convex or concave, is made up of. It is represented by the letter R. In the figure, the distance CP is the radius of curvature of the two mirrors. So, radius for any circle, it is the distance between the center and any point on the circumference. But here we take it as the pole, right? So, this is called radius of curvature and we keep it by the letter R. Next definition is for pole of the mirror. The central point on the surface of the mirror is called the pole of the mirror. It is represented by the letter P. A pole of the mirror can be found by drawing a straight line from the center C to the largest distance of the surface from C. Where the line cuts the mirror, you will find the pole of the mirror P. So here, how can we find the point P? So it is the largest line which connects the center of curvature C with the curved surface. So the largest, where it makes the largest distance, that point is called as the pole of the mirror. Or as I said, find the midpoint of the reflecting surface. Then that point is known as the pole of the mirror. Here is the definition for principal axis of the mirror. A straight line that passes through the center of curvature C and the pole of the mirror P is called the principal axis of the mirror. So in the figure, the line XY is the principal axis of the mirrors. The principal axis of a spherical mirror functions similar to the normal of a plane mirror. So normal of a plane mirror is a line which is 90 degrees to the plane of the mirror. Similarly, this principal axis acts as a normal to the curved mirrors. A ray of light passing through the principal axis will be reflected back along the same path. A very, very important point you have to know. A ray passing through the principal axis will be reflected back along the same path. So incident ray and the reflected ray will be same on the principal axis. Okay, and this is very important point. So a principal axis is a line which joins C and P, that is center of curvature and pole of the mirror. Next is the aperture of the mirror. You see to the diagram first. A spherical mirror is being taken. Since its reflecting surface is inside, it is a concave mirror, and P, as you all know, it is the pole of the mirror. C, it is the center of curvature of the mirror, and the distance between the pole and the center of the curvature is the radius of curvature. And you see to the straight line. The straight line touches both the ends of the reflecting surface of the mirror. So that distance is known as aperture. So now go to the definition. The portion of the hollow spherical surface from which the mirror reflection takes place is called aperture of the mirror. Focal length of a mirror. When parallel rays of light coming from an infinite distance fall on either a concave or a convex mirror, they are reflected back to a point on the principal axis xy. You see to the diagram, the first is the concave mirror. So parallel rays to the principal axis, they fall on the mirror and they get reflected, and all the reflected rays meet at the point F, where F is called principal focus. Principal focus. Okay. This slide explains you separately the the focal length of a concave mirror. So the concave mirror has the reflecting surface inside. It is shown by the blue color, and the non-reflecting surface of the mirror, it is on the outer side. It is shown by the dotted lines or parallel lines around the mirror. Now, principal axis is at the center, which passes through the focus and pole of the mirror P. Now consider the other rays. These rays are parallel to the principal axis. So rays which are parallel to the principal axis, after falling on the mirror, they get reflected, and all the reflected rays meet at the point F, which is called principal focus. So the distance between the principal focus and the pole of the mirror is the focal length of the mirror. This slide explains you the focal length of concave mirror. So here in the concave mirror, you have the reflecting surface outside and the non-reflecting surface inside. The reflecting surface is shown as blue color, and the non-reflecting surface is shown as dotted lines around the inner surface of the mirror. Now the principal axis is at the center, which joins the point P and C. C is the center of curvature. Now consider the other rays other than the principal axis. How are they? They are parallel to the principal axis. So rays which are parallel to the principal axis, after reflection, they move away, and if you extend those reflected rays, they try to meet at a point F on the non-reflecting surface of the mirror. So this F is called principal focus. So it seems all the rays are getting diverged from the point F. All the reflecting rays seem to diverge from F. So the distance between P and F, that is the pole of the mirror, and the principal focus, is known as the focal length of the mirror. Here it is the concave mirror. This slide gives you the relation between R and F, which means R is the radius of curvature. When you take capital letter F, it is principal focus, and when you take small f, it is the focal length. Now you see in the diagram here, the capital F, that is the principal focus, is the midpoint of the center of curvature C and the pole of the mirror P. Here it is wrongly given as S. And so yes, you have to consider P, which is the pole of the mirror. So F happens to be the midpoint of P and C. So that means P F is equal to FC. So what is the distance PC is called? It is the radius of curvature. So when radius of curvature is divided into two equal halves, so the first half, it is called the focal length. So focal length is the half of the radius of curvature. If the radius of curvature of a spherical mirror is 10 centimeter, then half the value, that is 5 centimeter, is the focal length of the mirror. Okay, the focal length F lies midway, that means the center between the pole P and the center of curvature C. The radius of curvature is found to be equal to twice the focal length. So the important formula R is equal to 2F. So when R is 10, F will be 5. When F is 10, R will be twice the focal length, 2 times 10, 20 centimeters. Okay. Now let us see to the types of image form. It's a very important one. There are two types of image. One is a real image and the other one is a virtual image. You must understand the difference between these two. When the image formed is real and when the image formed is virtual. So look at this diagram. You are familiar with this mirror. It's a concave mirror because its reflecting surface is inside. So an object above the principal axis, you find an object and the image of it is formed below the principal axis. You see the object here is a vase and it is erect, it is kept upright. Whereas when you see the image is inverted. The mouth of the vase is facing downwards, right? So the image is formed below the principal axis and it is inverted, right? And this type of images is called real image. So we will explain it more in the next slides. A virtual image, you see the virtual image, here the mirror taken is a plane mirror and AB is the object, or if you stand in front of the mirror, you are the object. Where is the image formed? The image is formed after the mirror, isn't it? In the previous case, the image is formed on the same side of the mirror. Now you got one point. So if the image is formed on the same side, it is real, and if the image is formed on the other side, it is virtual. We will discuss more about this in the next slide. This slide clearly shows you the types of images. Now you see in the diagram, reflection is taking place in concave mirror. It is a concave mirror. So rays after falling on the mirror, they get reflected. Because it is a mirror, it is getting reflected. Whereas on the right side diagram, you have convex lens. You will study more in detail in the next classes. So a convex lens is a bulged lens, right? And when a ray of light passes through it, refraction takes place. So refraction takes place in lenses. So when a ray of light falls on the concave mirror, it suffers reflection. On the other hand, when a ray of light falls on a convex lens, it suffers refraction. You know the difference between these two. We have studied in detail in the previous class. Now come to the concave mirror. So you can find a blue dotted line. A spot, a dot is being kept, and from the dot, the dotted lines of blue color goes and hits the mirror. So when they go and hit the mirror, they get reflected, and the reflected rays are shown in red color. So the image is formed on the red dot. So the blue dot represents the object, and the red dot, it represents the image. So the image is formed on the same side. Okay, and this is what is happening in the case of the concave mirror. Now come to the convex lens. The blue dot represents the object, and the dotted blue lines are the incident light rays, and they fall on the surface of the lens, and they suffer refraction, and after refraction the image is formed on the other side. So the red dot represents the image. Okay, so this will help you a lot in understanding the real and virtual image. So when the reflected or refracted rays actually meet, the image formed is known as real image. So in the above two cases, the rays of the light, they meet after reflection or refraction. So the image formed is real. A real image can be obtained on the screen. If you place a screen, the image can be obtained on it. A real image is always inverted. It is inverted. So this is the quality of the image formed for a real image. So if the image is to be real, the rays must meet each other, and it should be obtained on the screen, and it will be inverted. So all these qualities are the image. All these qualities are the real qualities of real image. This slide explains you the virtual image. Now you see the two diagrams here. One is convex mirror and the other one is concave lens. A convex mirror has a reflecting surface outside. So the blue color dot S is the source or object. And what happens? The dotted blue color rays hit on the surface of the mirror, and they go reflected in the same direction. When you extend those reflected rays, you get the dotted red rays. The dotted red rays meet at a red color dot where the image is formed. Now here the image is formed on the other side of the mirror. Come to the next diagram where a refraction takes place. The blue color dot S is the source or the object. The blue color light rays are the incident rays, and they strike the or get refracted by the concave lens. So you can see the red colored dots getting diverged. Okay, and the meet at a point with the red dot. Where is the red dot now? It is on the same side of the concave mirror. So in both the cases, the images are obtained by the extension of the reflected or refracted ray. Okay, now come to the sayings what it is given. When the reflected or the refracted rays do not actually meet, here in both the cases they did not meet each other, but they appear to meet at a point. The image formed is known as virtual image. The virtual image cannot be obtained on the screen. The virtual image is always erect. This table gives you the difference between real image and virtual image. First point, light rays actually meet to form a real image. They meet here. Here light rays actually appear to meet. They don't really meet, they appear to meet to form a virtual image. Here add the word appear to meet, right? And the second point, the image is generally inverted in the case of real. Real images are all inverted. The images generally formed is erect. Now you see the last column, that is the sixth one. Example, cinema screen. The cinema screen you all are aware of, and that is a best example for real image. And similarly for the virtual image, the plane mirror, where you stand in front of it every day, that gives you the virtual image. The image is obtained only on the plane mirror, and behind the mirror, if you keep a screen, you will not get the image. Okay, so the images is generally inverted in real image. You cannot ask, but I am not seeing in the cinema theater the upside, the inverted images. They are rectified by another lens, and it is the image what you see in the cinema theater is erect. Actually, the real images are inverted. The image is generally erect in the case of virtual image. Third point, the image can be obtained on the screen, and virtual image cannot be obtained on the screen. Fourth point, the real image is in front of the mirror and behind the lens. So the previous slides you have seen. So it will be in front of the concave mirror and behind the convex lens. Here the image is behind the mirror and in front of the lens. Okay, then the fifth point, we can reach to it. That means the real images can be reached and virtual images cannot be reached. An example, cinema screen and the plane mirror. So this difference between the real and the image, virtual image, is very important. So try to understand with all this by listening repeatedly till you get understand. Uses of concave mirrors. Concave mirrors are used in torches, searchlight and headlights of vehicles to get parallel beam of light. They are used as shaving mirrors to see large image of the face. They are used by dentists to see larger image of the teeth. Large concave mirrors are used to concentrate sunlight to produce heat in a solar furnace. So the uses are asked very frequently in the board examination for 2 marks or 1 mark or even 3 marks. Uses of convex mirrors. Convex mirrors are used as rear view mirror in vehicles. Convex mirrors give erect, diminished images of the object. They also have a wider field of view than plane mirrors. Now you can see the picture here. It is the rear view mirror of a car. So the most advantage of using convex mirror as the side mirror or rear view mirror is you can see the erect image. So you can see the trees which are erect. Erect means not inverted. Opposite of inverted is erect, right? And you can see a wider field of view. That means more images can be covered when you use convex. Because of these two reasons, convex mirrors are used as rear view mirrors. It's a very important board question. So convex mirrors are used as rear view mirrors. It is because it gives erect, diminished image of the object. They also have a wider field of view. That means more background can be seen in the mirror, right? Because of these two reasons, they are used as rear view mirrors. This is the last slide of the today's class, and so it is a sort of prevision for all the terms related to the spherical mirrors. Center of curvature is the center of the sphere of which the mirror forms a part, and it is represented by C. Radius of curvature is the radius of the sphere of which the mirror is a part. The distance Cp represents the radius of curvature. Pole is the center of the spherical mirror, and it is represented by P. Principal axis is the straight line passing through the center of curvature and the pole. Principal focus. In the concave mirror, rays of light parallel to the principal axis after reflection meet at a point on the principal axis, which is called as the principal focus. In the convex mirror, rays of light parallel to the principal axis after reflection get diverged and appear to come to form from a point on the principal axis behind the mirror is called the principal focus. Focal length is the distance between the pole and the principal focus. In a spherical mirror, the radius of curvature is twice the focal length. R is equal to 2f, or f is equal to r by 2. R by 2 is missing, so include that. That's the end of today's learning, children. So today I have taken you a limited number of hours, and because you have to understand the concept. So next week we will see about ray diagrams, drawing ray diagrams, which are very, very important for the board point of view. So, and today's assignment is you have to write all the definitions which you have come across so far, and you have to come across all the definitions which you have come across, and also you have to write the assignment for that. Okay.